Let's begin by exploring the basic concept of evaporation. Evaporation is a natural process where a liquid, most commonly water, transforms into a gas or vapor. This change occurs when molecules at the surface of the liquid gain enough energy to break free and enter the air. You've probably noticed puddles disappearing after a rainstorm or wet clothes drying on a sunny day. These are everyday examples of evaporation in action. It's a crucial part of the water cycle and happens all around us, often without us even noticing. Understanding evaporation helps us appreciate the invisible forces shaping our environment. Evaporation happens at the molecular level. When water is exposed to heat, the molecules start moving faster. Some of these molecules at the surface gain enough energy to escape into the air as vapor. This process doesn't require boiling. It can occur at any temperature, though it's faster when it's warm. That's why a puddle dries up more quickly on a hot day than on a cold one. The energy needed for evaporation comes from the surrounding environment, which is why evaporation often cools the surface left behind. We encounter evaporation every day, sometimes without even realizing it. When you hang wet laundry outside, the water in the fabric slowly disappears as it evaporates into the air. Sweating is another example. Your body releases moisture which evaporates and helps cool you down. Even a glass of water left out will eventually lose some of its contents to evaporation. These simple everyday occurrences show how evaporation is always at work, quietly shaping our routines and comfort. Evaporation is a key player in the water cycle, the process that moves water around our planet. When water from oceans, lakes, and rivers evaporates, it rises into the atmosphere as water vapor. Eventually, this vapor cools and condenses to form clouds, which later release the water back to Earth's precipitation. Without evaporation, the water cycle would come to a halt, and life as we know it would be very different. This invisible process keeps our environment balanced and thriving. Several factors influence how quickly evaporation occurs. Temperature is a major one. Warmer conditions speed up the process. Wind also plays a role by moving vapor away from the surface, allowing more molecules to escape. Humidity matters too. When the air is already full of moisture, evaporation slows down. The surface area of the liquid is important as well. A larger area means more molecules can evaporate at once. All these factors combine to determine how fast water turns into vapor in different situations. Let's take a closer look at temperature. When the sun shines on a puddle, it heats the water, giving energy to the molecules. The warmer it gets, the more energy the molecules have, and the faster they can escape into the air. That's why you'll notice puddles vanish quickly on hot summer days but linger during cooler weather. Temperature is one of the most noticeable factors affecting how fast evaporation happens in our surroundings. Wind is another powerful influence on evaporation. When air moves across the surface of water, it sweeps away the vapor that's just formed. This makes room for more water molecules to escape, speeding up the process. That's why laundry dries faster on a breezy day and why lakes lose more water when it's windy. Wind can make a big difference even if the temperature stays the same. Humidity refers to how much water vapor is already in the air. When humidity is high, the air is nearly saturated, so there's less room for more vapor. This slows down evaporation. On dry days, when humidity is low, water evaporates much more quickly. That's why sweat evaporates faster and cools you more effectively in dry climates than in humid ones. Humidity is a key factor in how comfortable or sticky the weather feels. Size of the exposed surface area also affects evaporation. A shallow pan of water will evaporate faster than a tall, narrow glass with the same amount of water. That's because more molecules are exposed to the air at once. This principle is used in everyday life, like spreading out clothes to dry or using wide trays to speed up drying processes. The more surface area, the quicker the evaporation. It's easy to confuse evaporation with boiling, but they're quite different. Evaporation happens at the surface of a liquid and can occur at any temperature. Boiling, on the other hand, happens throughout the liquid and only at a specific temperature, the boiling point. While both processes turn liquid into vapor, evaporation is a slower, more gradual process that doesn't require intense heat. Nature relies on evaporation in countless ways. Water from lakes, rivers, and oceans constantly evaporates, helping to regulate temperature and humidity. Plants also contribute through a process called transpiration, where water evaporates from their leaves. This not only cools the plant but also adds moisture to the air, supporting the local ecosystem. Evaporation is a silent but essential force in the natural world. Transpiration is a special type of evaporation that happens in plants. Water travels from the roots up to the leaves, where it escapes into the air as vapor. This process helps plants stay cool and draws nutrients from the soil. Transpiration also plays a big role in the water cycle, adding moisture to the atmosphere and influencing local weather patterns. It's a fascinating example of how evaporation supports life. One interesting effect of evaporation is cooling. When water evaporates, it takes heat energy from its surroundings. That's why sweating cools your body. Your sweat absorbs heat as it evaporates, lowering your skin temperature. This principle is used in many cooling technologies, from air conditioners to cooling towers and power plants. Evaporation is nature's way of keeping things cool. Industries use evaporation in many ways. For example, salt is harvested by letting seawater evaporate in large shallow ponds, leaving the salt behind. In food processing, evaporation concentrates flavors or removes excess water. Chemical industries use evaporation to separate substances or purify solutions. This process is a vital tool in manufacturing and production across the globe. Cooking often relies on evaporation. When you simmer a sauce, water evaporates, making the sauce thicker and more flavorful. Boiling pasta or rice also involves evaporation, as some of the water escapes as steam. Even baking uses evaporation to create the right texture in bread and pastries. Understanding how evaporation works can help you become a better cook and control the outcome of your dishes. Any products we use daily depend on evaporation. Perfumes and colognes release their scent as the liquid evaporates from your skin. Paints and inks dry through evaporation, leaving behind color and design. Even cleaning products often work by evaporating quickly so surfaces dry fast. Evaporation is a hidden helper in countless items around your home. Evaporation plays a big role in shaping our weather. As water evaporates from oceans and lakes, it adds moisture to the air, which can lead to cloud formation and eventually rain. This process helps regulate temperature and humidity, influencing everything from local breezes to global climate patterns. Without evaporation, our weather systems would be very different. Farmers pay close attention to evaporation. Too much evaporation can dry out soil and harm crops, especially during hot, windy weather. On the other hand, controlled evaporation is used to dry grains and preserve food. Understanding evaporation helps farmers manage irrigation and protect their harvests, making it a key factor in agriculture. Evaporation is a common topic in science experiments. Students might observe how quickly water evaporates under different conditions like varying temperature or wind. These simple experiments help illustrate scientific principles and make learning hands-on and engaging. By watching evaporation in action, students gain a deeper understanding of the natural world. Evaporation is all about energy transfer. When water molecules absorb enough energy, they can break free from the liquid and become vapor. This energy comes from heat, which is why evaporation cools the surface left behind. The process is a great example of how energy moves and changes form in our environment, connecting physics and everyday life. Desalination is the process of removing salt from seawater to make it drinkable. One method uses evaporation. Seawater is heated until it evaporates, leaving the salt behind. The vapor is then condensed back into fresh water. This technique is used in many parts of the world where freshwater is scarce, showing how evaporation can solve real-world problems. Artists sometimes use evaporation in their work. Watercolor painters rely on evaporation to create unique textures and effects as the paint dries. Some sculptors use materials that change as they lose moisture, adding an element of time to their art. Evaporation can be a creative tool, shaping both the process and the final result. Evaporation affects our health in many ways. Sweating is the body's natural cooling system, relying on evaporation to regulate temperature. In dry environments, evaporation can lead to dehydration if you don't drink enough water. Humidifiers add moisture to the air, slowing evaporation from your skin and helping you feel more comfortable. Understanding evaporation can help you stay healthy and hydrated. On a global scale, evaporation influences climate. Large bodies of water like oceans release vast amounts of vapor into the atmosphere, affecting weather patterns and rainfall. Changes in evaporation rates can impact droughts, floods, and even long-term climate trends. Scientists study evaporation to better understand and predict changes in our planet's climate. Modern technology often uses evaporation in clever ways. Cooling systems in computers and power plants rely on evaporation to remove excess heat. Some air conditioning units use evaporative cooling to keep buildings comfortable. Even certain medical devices use evaporation to deliver medicine or maintain sterile conditions. Technology harnesses evaporation to solve everyday challenges. Evaporation has been used by humans for thousands of years. Ancient civilizations harvested salt by evaporating seawater in shallow ponds. Early methods of preserving food like drying fruits and meats relied on evaporation. Even traditional pottery and brick making use evaporation to harden materials. This simple process has shaped human history in countless ways. Evaporation can help save energy. Evaporative coolers, sometimes called swamp coolers, use much less electricity than traditional air conditioners. By harnessing the natural cooling power of evaporation, these devices provide comfort while reducing energy costs. This makes them popular in dry, hot climates where energy efficiency is especially important. Water conservation efforts often focus on reducing evaporation. Farmers use mulch or cover crops to keep soil moist and prevent water loss. Reservoirs and swimming pools may use covers to slow evaporation. These strategies help save water, especially in regions where every drop counts. Managing evaporation is a key part of sustainable water use. Athletes rely on evaporation to stay cool during intense activity. As they sweat, the moisture evaporates, helping regulate body temperature. Sports clothing is often designed to wick moisture away from the skin and promote evaporation. This keeps athletes comfortable and performing at their best, even in hot conditions. Wildlife depends on evaporation too. Animals cool off by panting or sweating, both of which rely on evaporation. Some desert animals have adapted to minimize water loss by reducing evaporation from their bodies. These adaptations help them survive in harsh, dry environments where water is scarce. Cities experience evaporation in unique ways. Urban heat islands, where cities are warmer than surrounding areas, can increase evaporation rates. Fountains, parks, and green roofs use evaporation to cool public spaces. Even the design of buildings and streets can influence how much water evaporates in urban environments. Evaporation can sometimes carry pollutants into the air. When contaminated water evaporates, some chemicals or toxins may become airborne. This can affect air quality and pose health risks. Scientists monitor evaporation in polluted areas to protect people and the environment, highlighting the need for clean water sources. In disaster situations, evaporation can be both a challenge and a solution. After floods, evaporation helps dry out affected areas, but it can also spread contaminants. Emergency teams sometimes use evaporation to purify water or speed up recovery. Understanding evaporation is crucial for effective disaster response and recovery. Power plants often use evaporation to cool machinery and manage waste heat. Cooling towers release water vapor into the air, helping maintain safe temperatures. This process is essential for efficient energy production and safe operation. Evaporation is a behind-the-scenes player in keeping our lights on and our homes powered. Transportation systems can be affected by evaporation. For example, fuel tanks are designed to minimize evaporation losses, which can be both costly and harmful to the environment. Road surfaces can also dry out quickly after rain, thanks to evaporation, improving safety for drivers. Managing evaporation is part of keeping transportation efficient and safe. Architects sometimes design buildings to take advantage of evaporation. Features like water walls, fountains, and green roofs use evaporation to cool indoor and outdoor spaces. These designs can reduce energy use and create more comfortable environments, especially in hot climates. Evaporation is a natural ally in sustainable architecture. Recreational activities often involve evaporation. Swimming pools lose water to evaporation, especially on hot, sunny days. Outdoor sports fields may need extra watering to replace moisture lost through evaporation. Even camping and hiking gear is designed to dry quickly, making use of evaporation for comfort and convenience. Museums and collectors must manage evaporation to preserve artifacts. Too much evaporation can dry out delicate materials like paper, leather, or wood, causing them to crack or deteriorate. Climate control systems help maintain the right balance of humidity, protecting valuable items for future generations. Space missions must consider evaporation in extreme environments. On planets with thin atmospheres, liquids evaporate quickly, posing challenges for storing water or fuel. Engineers design special containers and systems to minimize evaporation and ensure astronauts have the resources they need. Evaporation is a key factor in exploring new worlds. Innovators are finding new ways to use evaporation. Solar stills use sunlight to evaporate water and collect fresh drinking water, even in remote areas. Engineers are developing materials that control evaporation for better cooling or water conservation. These creative solutions show how understanding evaporation can lead to breakthroughs in technology and sustainability. Artisans use evaporation in crafts like pottery, papermaking, and dyeing fabrics. The drying process is carefully controlled to achieve the right texture and finish. Too much or too little evaporation can affect the quality of the final product. Mastering evaporation is part of the skill and tradition in many handmade crafts. Gardeners manage evaporation to keep plants healthy. Watering early in the morning or late in the evening reduces evaporation, helping soil stay moist. Mulch and shade can also slow evaporation, conserving water and supporting plant growth. Understanding evaporation helps gardeners create thriving, sustainable gardens. Fashion designers use fabrics that promote or resist evaporation depending on the need. Athletic wear is designed to wick moisture and dry quickly, while raincoats and umbrellas block evaporation to keep you dry. The science of evaporation influences the comfort and function of the clothes we wear every day. As the climate changes, evaporation patterns are shifting. Some regions face more drought while others see increased rainfall. Scientists and engineers are working to understand and adapt to these changes, developing new ways to conserve water and manage resources. Evaporation will continue to be a key factor in our relationship with the environment. Evaporation is a simple yet powerful process that shapes our world in countless ways. From the water cycle to technology, health, and art, it touches nearly every aspect of our lives. By understanding evaporation, we can better appreciate the invisible forces at work around us and find new ways to harness its benefits for a sustainable future.